substitutional nature, and then anomalous concentration of REE. Here I stop at this juncture because apatite is a carrier mineral for rare earth elements. Please note this point. Tomorrow, if you are asked to look for rare minerals, you cannot locate a badillite or zirconite and then say, I have located a mineral. They want elements. They want either a beryllium or a neodymium or a lanthanum or cerium. You give them elements. So tomorrow there would be a search for rare elements sensu stricto. Here what I could find at that time was this apatite, this fluor hydroxyapatite was containing an unusual concentration of rare earths. So crystal chemically they are all going into the substitutional nature of the cation. How does it enter? I cannot say because ultimately the formula of apatite stands there. Ca5 F PO4 twice. That is the formula I think. Ca5 F PO4 twice. This formula, if it is doubled, Ca10 F2 PO4 6 times, 4 times it comes. But Ca10, 10 cations are there in that host. So rare earths also are entering into that cation structure. And PO4 is substituted by, F is substituted by this hydroxy. So it is a substitution of both cations and anions. Here cations, rare earths are entering the calcium site and they are good concentrations. So supposing calcium is theoretically supposed to be 58% in an apatite, theoretically 100% basis or 55%. So actually if you analyze, it won't be 55%. It will be something like 52 or 51. Rest 4 is rare earths. They are occupying the same site. So this type of fundamental approach in understanding a carrier mineral or an index mineral is what will lead you to understanding the rare earth elements. Rare earth elements will never occur as discrete mineral phases. They will never occur as massive concentrations. Never. Even in low concentration, you have to concentrate by all your techniques. So they always occur in traces or in higher quantities. You have to trace them. You have to find out. You have to find out a method of concentrating it. Here, rare earths, I am telling you, it is absolutely rich. How many elements are there? I will tell you. I won't put any questions. There are 14 rare earth elements. 1, 4. Why that 114 only? 14 only? You can ask the F group elements. There are 4 groups of elements from electronic point of view. S, P, T and F. F group always contains 14. That is a thumb rule because only 14 electrons enter into that F group. So if you see the periodic table, it will be ending with 14. So these are the 14 elements. All the 14 except europium are present in this apatite. That is the thesis premise on which I got my doctorate. I wrote there, this is an unusual apatite, it is rich in rare earths and it is an unusual environment. That is what I wrote. So for this wording only, the examiners gave me a PhD. They never looked at other pages. Because other pages are well known. I should have described the garnet of a chondrolite. Everybody knows. This feldspar, pinkish and reddish, sometimes not pinkish, is a rubbish. What is the point in it? The crux of the problem you have to highlight. So here I am telling you, your apatite is a carrier mineral and in addition to that there is a zircon. In the same mineralization, there is a zircon. Amber colored zircon crystals I have seen up to the size of 4 to 5 inches. And small zircon crystals embedded in a feldspar matrix. Of course, now there is nothing. This is all a story I was telling you about 50 years ago. I saw the mineralization. So, unusual minerals only carry unusual elements. This is a thumb rule. You can find an iron ore here and there. You can find a hematite, you can find a magnetite. But you cannot find a lanthanum mineral or a cerium mineral unless you locate the host. So next one.